This is May 19, time zone 1, paper 1, question 7. Right here, so this is a derivative question, and you want to recognize that it's an implicit differentiation question. Now, how would you recognize that? Poya, how would you recognize this?
I believe.
So you have an implicit differentiation question when you have, normally we have x defined in terms, y defined in terms of x. Y equals 2x squared, y equals 3x. Here we don't have that. We have our function defined in terms of x and y. And we want to find the coordinates at which dy dx equals 0. So if we start by deriving both sides with respect to x, now the derivative of y cubed with respect to x, I don't know what it is.
It's 3y dy dx.
It's 3y squared
Squared
times dy dx. Because I don't know how y, the derivative of y relates to x, because y is not defined in terms of x. All right, so the whole thing is going to be 3y squared y prime plus, here we've got the product rule.
Yeah.
3 times the derivative of the first times the second plus the first times the derivative of the second, and we again have the chain rule right there, minus 3x squared, and this is equal to 0. Now I'm going to solve this for y prime. This is this part right here. Well, let me just expand the whole thing out to be super clear, that way it'll be easier. So far, so good? Okay. I really could divide everything by 3 if I wanted to at this point. Do you see how we can divide everything by 3? So, do you want to do that, or do you want to not simplify first?
I did it for simplify.
You first just simplified, so here's how, I'm going to divide everything by 3 here. So I'm going to get y prime, y squared, plus y squared, plus 2xy, y prime, minus x squared, equals to 0. I want to factor the y primes. Then I'm going to isolate y prime as best I can, so I'm going to start by, and you don't need to show all of this, but it doesn't hurt. Therefore, y prime x squared minus y squared over y squared plus 2xy. And now the question is, we want to find the coordinates, that's the x and y value, at which this is equal to 0. Well, y prime will equal 0 when x squared minus y squared equals 0, or when x squared equals y squared. Right? I need my numerator to equal 0. Now, if x squared equals y squared, I'm going to take the square root of both sides. So y is equal to plus or minus the square root of x squared. The square root of x squared is plus or minus x. So what I'm going to do now is go back to my original equation right here and find the value of y when y equals x. Or find the value of x when y equals x. So I've defined y in terms of x, so I'm going to find the value of x when y equals x. So at y equals x, my whole function, 27, is going to equal, instead of x, instead of where there's a y, I put an x. 3x x squared minus x cubed. Well, these two cancel out. 3x cubed is 27. X cubed equals 27 divided by 3 is 9. So that x is equal to the cube root, careful, of 9. I don't entirely know what it is, but I do know that that means that when x is equal to the cube root of 9, y is also equal to the cube root of 9, because x is that y equals x. So this
Positive
is,
x.
yes, these are some of the coordinates. And y equals minus x. 27 is going to equal, and now it's using this right here, minus x cubed. So just to be plus 3x minus x squared minus x cubed. Does that make sense? I've replaced the y's with minus x. Now, minus x cubed is minus x. So here, I'm gonna end up with 3x cubed minus 2x cubed. So that'll be x cubed equals, no. Yes. Just to be clear, y cubed, y is equal to minus x cubed is minus x cubed. Well, then this is what I get. This will be 3x cubed minus 2x cubed equals x cubed. I'm a little surprised. I think the one I saw before wasn't that. Because here I've got that x is equal to the cube root of 27. Something about that seems mildly off. Let's look back up here. Minus x cubed plus 3x cubed equals x cubed. Okay, well then, this is what I have. The cube root of 27 is, I don't know. It's 3. 3 times 3 is 9, times 3 is 27. So therefore, when x, so the x equals 3, and y is equal to minus 3. Well, that would be right if I'm right.